The only experiment in the world to grow semiconductors in space has started in Russia. It paves the way for the creation of entire orbital factories and moving many harmful industries beyond Earth. Essentially, it's the industrialization of outer space. We'll talk about this, about the new National Space Center in Moscow, about why the Chinese have started building data centers in orbit, and also about a hero. After a brief summary of positive news. The Soyuz 2.1B launch vehicle successfully lifted off from the Plesetsk Cosmodrome and placed a spacecraft into orbit, in the interests of the Ministry of Defense. Another batch of Su-34 fighter bombers and new BMP-3 and Boyevaya Machina Desanta, 2 vehicles have been delivered to the troops. The heavy nuclear missile cruiser, Admiral Nakhimov, has successfully completed the first stage of sea trials after modernization. An ice-class tugboat has been laid down in Crimea, and production of stamped parts for the automotive industry has started in Tolyatti. Chelyabinsk Mechanical Plant opened a new full-cycle complex to manufacture import-substituting equipment. A breeding and seed center opened in Lipetsk, a large food facility in Astrakhan, and a robotic dairy farm in Udmurtia. Russian school children won 6 medals at the International Junior Geography Olympiad and 6 medals at the Olympiad. On September 11, 2025, the Russian Soyuz 2.1A launch vehicle successfully lifted off from the Baikonur Cosmodrome and delivered another cargo ship with supplies of fuel, water, and food to the International Space Station, as well as scientific equipment, including for conducting the one-of-a-kind Ekran M experiment on growing semiconductors in zero gravity. Only a few people paid attention to this event. Meanwhile, it had already occurred. It promises to open a new era in the exploration of outer space on Earth. Semiconductor materials, which are subject to higher requirements, are grown using the so-called molecular beam epitaxy method. For this, atomically thin layers are stacked on top of each other in a special chamber, and from them, a semiconductor crystal with the required properties is formed. The difficulty is that an ultra-high vacuum must be created in the chamber, where for every billion atoms of the synthesized material, there's only one for an atom. It's expensive and complicated, but why not move the process into open space to use, so to speak, the natural free vacuum in orbit? The solution seems obvious, but it's more complex than it looks. The thing is, the vacuum in space also varies. At high orbits, it's very pure, which is perfect for manufacturing. But sending equipment up there is expensive. At lower orbits, for example, where the International Space Station is located, the vacuum is less pure, but delivery there is cheaper. However, micrometeorites and stray atoms can get into the working area of the equipment and ruin everything. Aristotle found a solution to this problem long ago, suggesting that a stone released from a sling pushes molecules aside and creates an empty space behind it. In the same way, the International Space Station, moving along its orbit, creates a cleaner space behind it. It's so clean that it's impossible to recreate it on Earth. That's why it was decided to place the semiconductor growing facility right behind the International Space Station and to cover it with a special shield for extra protection. That's where the name of the experiment, Screen M, comes from. The very idea of creating space laboratories was first proposed back in the 1960s by an American of Slavic origin named Kostov. According to his calculations, at the first cosmic velocity, a region forms behind a flying object where there is practically no matter. Practical implementation began in the 1990s by Professor Alex Ignatiev, an American with Russian roots from the University of Houston. The experiments began aboard the shuttles, but were discontinued after the Columbia disaster in 2003. Meanwhile, Russian scientists from the Institute of Semiconductor Physics, of the Russian Academy of Sciences not only revived the idea, but also took it to a new level. Thanks to being placed on board the International Space Station, the experiment became long-term, and now cosmonauts can change the equipment setup, the technological process, and load and unload materials. The experiment has already started, and a unique Russian installation was created for it, as well as many non-trivial engineering challenges were solved. Since the synthesis occurs in microgravity, unlike on Earth, it brings unique challenges and benefits. At the moment, no one else in the world is doing anything like this, and we have every chance to create the first experimental industrial factory in space. But what is it needed for? We started the experiment by producing gallium arsenide, one of the most popular semiconductors, which is used in power electronics to make lasers, photodiodes, and solar panels. The last point is the most promising. The thing is, solar panels based on gallium arsenide have a very high efficiency and are perfect for use in space. Launching them into orbit is costly, but synthesizing and assembling them in space is entirely different. This will make it possible to service satellites and other devices in orbit, and will significantly extend their lifespan. The creation of other electronic components also expands the possibilities for industrial development of near-Earth space. If you read the news carefully, it's already beginning. For example, in the spring, the Chinese launched the first batch of satellites with artificial intelligence for a space data center. In the future, 2,800 such devices will be combined into the first orbital supercomputer using laser communication. It will allow data processing, for example, from remote sensing satellites directly in space, not on Earth. So we see that both computing and manufacturing are already looking for their place in space, which makes sense. It also has an advantage. It's eco-friendly, since chemical production on Earth is often hazardous to humans, but in space it's harmless. For now, our experimental setup is quite small and is needed for testing the technologies. If successful, a whole module could be dedicated to it in the Russian orbital station. Now under construction. And in the future, it could even be placed on board a special spacecraft that would follow the station in unmanned mode, approaching only for loading and unloading materials and finished products. One way or another, humanity is confident. We'll master near-Earth space, and sooner or later, all kinds of factories and assembly production will start working here. Russia has taken an important step toward this. Now we need to move forward, and for that, strategic planning is necessary, and this is what we are doing. At the end of last week, a complex of buildings of the National Space Center was opened in Moscow. It will unite the Roscosmos central office, headquarters of rocket and space industry firms, design bureaus, prototype production, and the new orbital station's control center. That's roughly 12,000. Employees will be able to work in comfortable and modern conditions, which is especially important for attracting young professionals. And this is exactly our strategic approach, because science will continue to develop only if it is constantly replenished with new talent. But that's not all. The National Center itself is not just a large office, but the heart of a giant technological cluster being created around it. An innovative industrial technopark with an area of 1.5 million square meters will be built there, where both new enterprises from the space industry and related sectors will move in. In total, more than 30,000 new jobs are being created. So the most interesting part is just beginning. We will keep an eye on the developments and keep you informed in future episodes.